All right, so this last weekend we learned how to find the derivative, that is the slope at a given point um, on a curve. Um, and we did that using the method of differentiation. And now what we're going to do is, now that we know how to find the slope, we're actually going to work to find the equation of the tangent line. So this is how we do that. So the first thing we're going to do is I'm going to give you a function. So I'm going to say, let's say p of x equals, let's say 4x squared minus 5. Okay, so if I were to sketch this really roughly here, I know that my y-intercept is down at -5, so let's say that is here. And then I know that this parabola is narrower because a is 4 than the parabola of the parent function, which is x squared. That's a really horrible looking parabola here. Remember, these are supposed to look symmetrical, which they don't. All right. So let's say that I want to find the equation of the tangent when x equals 2. Okay, so the first thing I need to do is I need to go ahead, and if I'm going to find the equation of a tangent line, I need to know the y-coordinate that goes with this x value. So what I'm going to do is I'm going to put in 2 everywhere I see x to find y, or in this case p of 2. Alright, so when I do that, order of operations says, because I'm doing expressions, so I'm working from p to s, because I'm not moving anything over the equal sign, I have to deal with my exponents first, because there's nothing in parentheses to simplify. So 2 squared is 4. Okay, and now I'm going to do multiplication and division. So 4 times 4 is 16 minus 5. So my y value, when x is 2, is 11. So I'm dealing with the coordinate 2, 11. So that's, we'll say somewhere like up here. Okay, so it's the tangent line here. Okay, very badly drawn tangent line. All right, so let's go ahead and try to get rid of some of this. Okay, but not that. Let's try this again. Okay, so at this point, now that I know my x value and my y value, I'm just gonna leave that there. Okay, I'm gonna go ahead and I'm gonna differentiate p of x. Okay, so p prime of x. Okay, so the exponent kicks out front, so I end up with 2 times 4x squared, and then I take away 1, so that's the differentiation. And then the minus 5, well, when I differentiate a constant, as we talked about in class today, I end up with 0, so there's nothing there. So I end up with 8x being the gradient equation as our book says it. So now I need to go ahead and find the gradient. So the way I find the gradient is I take my x value, and everywhere I see x, I put in 2. So this is going to tell me the gradient when x is 2. So as I suspected, this is a pretty steep gradient, 16. Okay, so now, if you remember, the equation of a line is y equals mx plus b, and our derivative is our gradient, so we could also say that m equals 16. So I'm going to go ahead, and everywhere I see y, I'm going to put in 11. Okay, so there's 11 equals. Everywhere I see m, I'm going to put in my derivative, okay, which is my slope. That's why I can say the derivative is 16, or the slope is 16, because they're the same. Everywhere I see x, I'm going to put in 2. So this is exactly like we've done in the past, writing the equation of the line, and what we don't know is the y-intercept, so that's what we need to find. So I'm going to go ahead and simplify this. 16 times 2 is 32 plus b. Okay, subtract 32 from both sides. So I end up with negative 21 equals b. Okay, so my final equation for my tangent line is y equals my slope, which is 16 times x minus 21. Okay, so there's the equation of my tangent line.